morning and welcome to a soil science laboratory at Washington State University in Pullman, Washington. I am Summer Lockhart, and today I'm going to show you how to construct a soil mesocosm for measuring soil respiration in incubations with an attached CO2 sensor to the top of the mesocosm and a Arduino-based low-cost Arduino-based monitoring platform or CO2 lamp to continuously measure the CO2 production by the microbes in this system. This system is based off of a system made for hydrogeological applications by Joshua Blackstock et al. You can see their paper published in 2019. I have linked it in the subscription for more details on the original conception and construction of this sensor. I've modified this sensor to use in a laboratory setting, but it can also be connected to battery to use in the field if you want to do incubations in a field setting without line power available to you. So let's go ahead and get started and build ourselves a mesocosm. All right, so the first step to building a mesocosm is gathering all of your supplies. And I'm just going to ask you guys to excuse the mess in this lab. Anybody who has ever worked in crops and soil science knows that summertime is field season. And so we tend to get inundated with coolers, boxes. We've got some buckets of soil, various different things that get collected in a lab during field season as we are all frantically working, and the lab doesn't necessarily get cleaned up right away. Also, it's a soil science lab, so it tends to get a little bit dirty. Okay, so first things first, we need all of our supplies. So I've got my mason jar, which is the primary container that I'm going to be putting my soil in to let them incubate, and it's going to help me trap all of that CO2 in a closed space so that I can measure it with my CO2 sensor. I have a couple different choices for wide mouth mason jar lids. These white ones, these are Mason Top's Tough Top mason jar lids. It has a little rubber gasket on the inside of it. I'm not sure yet how this one's going to work. I've never used this one before, but I wanted to try it out and see if I can get a really nice seal with it, because one of the challenges with these mesocosms is making sure that you get a nice airtight seal. The other thing that I have is another lid that I also haven't used this brand before, but it is essentially the same lid that I'm using on my other mesocosms. This is a Ball branded wide mouth plastic mason jar lid. Next, of course, I have my CO2 sensor. This is the Sensair K30 10% CO2 sensor that goes up to 100,000 parts per million. Some people, when they are using sensors for other applications, will use the 1% sensor, especially if you're going to be doing CO2 measurements out in closer to atmospheric conditions. But in soils, CO2 concentrations get really, really high just due to the need for a concentration gradient for the CO2 to get out of the soil. And so I tend to work with higher concentrations. So I like this little bit more expensive K30 CO2 sensor with the 10% calibration level. The next thing that I have is my Stanley sort of tackle box toolbox that I use. This is a really handy little toolbox just to keep everything organized. My workbench, because I'm always making CO2 sensors, tends to get messy, covered in little bits of wire and solder and various and sundry components. So I went ahead and bought this like $18 little tool chest to keep everything organized. In here, I've got my soldering iron, my wire strippers, I've got some epoxy, I've got more epoxy. I have some Grove 2-coil latching relays that I will use as a component for these mesocosms. I also have some 6-volt step-up, step-down voltage regulators, again, that I use for these mesocosms. I've got some Arduino data loggers still in their boxes back here, and some Adafruit data logging shields. I just buy these when I go and I buy them. I buy multiple at the same time because they're all relatively inexpensive. I think the most expensive thing in here is maybe the Arduinos, which are like $27. I've also got some wire of various different colors. I've got my Dremel tool. There's some tubing and some hypodermic needles that I use to put gas in and out of my mesocosms. And then I have some lead-free solder. And then I also have a little wire sponge thing for cleaning my soldering iron, and some rosin flux paste that I use as part of my soldering equipment. Oh, and some power cords for powering the Arduinos. The other thing that I have is I have a box of just various different sizes of jumpers for my Arduinos. I can either use these stacking headers to plug wires and move wires around if I'm testing out something new. But what I use them most for these mesocosms is actually these non-jumping headers that we've got in the middle, just because sometimes the ones that come with the Adafruit data logging shield, they break off in a weird number, and I just find that I like to have extras around just in case. The other thing that I have that is not necessary is a heat gun and some heat shrink tubing. I use this instead of electrical wire on all of the various different wire joins that I use. I like having this tubing and heat gun. It was pretty inexpensive. And it's really handy just for kind of keeping my wires neat and tidy and making sure that if anybody does wander into the lab and touches one of my sensors, they're not going to get themselves a little shock. The next thing that I have here is some Plasti Dip. I have a very high-tech method of sealing this canister. It is some tape with a glove over the top of it. The lids on this brand of rubber coating just are terrible. And so it dries out really, really fast. You end up wasting a lot of money buying this over and over and over again. They're not super expensive. I want to say it's like $10 for a big container like this, but I don't want to have to constantly be replacing it. And so I wrap it up with tape and then cover it with a glove, and that tends to help. And then I have some paint brushes that I use to paint that Plasti Dip on. I have some iChem vial lids with septa. I prefer these iChem vial lids and septa because the septa do not pop out of them. They're glued in, and so when I've got a completed mesocosm, I don't have to worry about the septa popping out and me having to try to find a way to affix that septa to the system. And then the next thing that I have, it's kind of messy, but this is duct seal, also known as electrical putty. I use this as extra sealant on my mesocosms. You can see on this mesocosm back here, I have sealed up sort of the edge of the lid with this duct seal just to make sure that it is extra airtight. Then of course I have my MacBook and a serial cable. It's just a printer cable and a dongle so that I can connect it to my MacBook. And then I have a notebook, some gloves for anytime I have to touch something sticky. And then I have here some templates that I have made to go ahead and draw on the top of my lids the shape of the sensor portion of this sensor. And I will go ahead and show you how I make these templates, but we're going to have to go across campus to my office to do that. So let's go ahead and do that now. Welcome to my office on the other side of campus. So I need to make a template so that I can cut those lids. And I have a couple things that I like to use to do that. One of those is some graph paper. And then I have the actual sensor itself and a ruler. And what I'm going to do is I'm going to take the ruler and the sensor and I'm going to put them both on the graph paper. I'm just going to switch the camera around and show it to you. And so once I have those guys lined up on the paper, I'm going to go ahead and take a photo just like this, as straight as I can possibly get it. Okay, and then once I have that picture, I'm going to go ahead and transfer that to my laptop, which I'm screen recording right now so that you can see what I'm doing. So once I have that image on my screen, I'm going to tidy this up a little bit because you can still see my picture of my computer and my office floor in the background, and I don't need all of that. I just need the part with the ruler and the sensor so that I can get the right size of it. So I'm going to go ahead and crop it first. And then once I have it cropped, I'm just going to go ahead and I'm going to print it. And right now we've got it scaled to about 21%. So I'm just going to print it at that 21% scale and see how it looks. Okay, and I've got that printed piece of paper out, and this is that 21% that I printed. And I'm just going to take my sensor and lay it over the top and see how close we are. And it looks pretty close. Oops, just spinning that all over the place. It looks pretty close, just right on the first try. So I'm going to take my ruler and double check it. man, it looks like 21% was just dead on, which doesn't happen very often. Usually I have to print uh, several different times at several different percentages and check it with my ruler over and over and over again to get the right size. This is pretty stinking close. And so I think that's going to be good enough to make our template, because our template doesn't have to be dead on. Okay, so now that I have a properly sized template that I've measured and made sure that the paper copy is the same size as my actual sensor, I can go ahead and just with scissors, just cut out the sensor portion of this piece of paper. So I just want the sort of silvery chrome section around that white section that's just the sensor itself, so that I'm not actually cutting out the whole circuit board size. We want to cut as small of a hole as possible in the top of that lid to make sure that we've got as few opportunities for leaks as possible, and to just make the whole thing a little bit tidier and easier to use. So I have my template. I can take this back with me to the lab, along with some extras that I printed out, because better safe than sorry. You always want to have extra templates around so that I can make additional sensor and Mesocosm sets in the future, and I don't have to go through this whole picture and printing rigmarole every single time. So I've got my set of templates. I'm going to go ahead and pack my sensor back up into its static proof bag and its bubble wrap, and we're going to go back across campus to the soil science lab over in Clark, and I will show you the rest of the process over there. Okay, so the first thing that I like to do is go ahead and get my lids done. This is my least favorite part, which is why I like to do it first and get it done and over with. What I'm going to be doing here is I'm going to be drilling a hole on the top of these mason jar lids. I'm going to do both of them because I want to see how they act, because like I said, these are both new lids that I haven't tried to use before, and I'm going to drill them out with this Dremel tool. And when I do that, the Dremel tool is going to actually melt the plastic a little bit on top, and it's going to fling little bits of plastic everywhere. I'm going to have to periodically stop to remove the plastic that gets stuck to this little cutting bit that I have on my Dremel tool. And so that's part of the reason why it's my least favorite part. We end up with like a lot of little bits of plastic all over the place. Wear goggles for the safety goggles for this to protect your eyes, and just be very careful, because this Dremel tool can jump and then scrape up and or cut your hands while you're doing it. But the first step is to figure out exactly where I'm going to put this. So I have my template, which I am going to put face down on the top because that's the direction that I need it to go. And I'm going to use my actual physical sensor to sort of get an idea of exactly where I want to place the template on both of these. So, and I want to make sure that when I place this template, that it's far enough away from the edges of this lid that this little gasket sort of, on the ball jar, it's a firm plastic ridge, so that that goes against the top of the mason jar that seals it shut. I want to make sure I don't cut into that. So I want to make sure that my sensor is far enough in that I'm not going to do that. That's going to be even trickier on this white lid with the actual physical gasket in here, just because this little gasket it takes up more space on the inside of the lid. So I'm going to have to work a little bit harder to make sure that I get all the way in. But the nice thing about these lids is there's a little ridge on the outside that lines up with where that ridge is on the inside, so I can't actually see from the top where that is located. So first things first, with my sensors and some markers, I'm just going to kind of place the sensor where I want it, get a good idea of how I want it to go. And the reason I do it this way is because you don't want it to be like long ways across. You want to make sure that you have plenty of room in here, because I'm also going to need to fit that iChem vial lid with the septa onto this lid. Now, if you don't need to introduce gas into your mesocosms, then you don't necessarily need to have room for that iChem septa, and you can just go dead center in the middle. For me, because I am doing experiments where I'm testing how microbial respiration rates respond to elevated CO2, I have to have a way to change the concentration of gas inside of those mesocosms, which is why I need this little septa here. But this is absolutely an optional part. If you're just going to use these to do incubations and save yourself the trouble of having to do gas straws and things like that, you don't need to be able to fit this gasket. Septa, not gasket, sorry. Okay, so then once I think I've got it lined up properly, I'm just going to take my marker and I'm going to draw around the edges of that template that I made. Okay, and once I've drawn my shape on here, I'm gonna again take my sensor and I'm just gonna line it up inside of that shape. And I can kind of see the sensor from the side, but you can't really get a pen under there, which is why I had to make a template. I'm just gonna line it up inside of that shape that I've cut and make sure that it's gonna fit the way that I want it to. And still leave me space, like I said, on top for me to fit that gasket or that septa in, and I can just barely fit that septa lid in with it the way that it is. So I'm going to go ahead and cut it in this shape. But first I'm going to go ahead and do the same thing on my white lid, and then I will do all the dremeling of both of those, and I will speed that up because you don't need to watch every minute of me dremeling. Okay, so you can see the sort of general mess that I have made with bits of plastic all over my bench. So I got to sweep this up a little bit, but you can also see how this guy fits in there. And let's just go ahead and see if the sensor also fits nice and tidy still. So yeah, we've got my sensor and we've got my septa both fitting into the lid. I've cut my holes. You can see on the underside, all of that gasket is still intact in that ridge. And I think I like this white plastic guy a little bit better. This is the Mason Tops Tough Top lid than this ball lid, just because the hard plastic on this ball lid is just a little bit more rigid, and I just don't quite think that it's going to seal quite as nicely. Plus the raised edge on this one, just the way that it is, really tilts the sensor a little bit more. So I'm going to keep this on hand. I will make another sensor at a later date, probably using this lid that's already cut, and see how well it seals and compare it. But for today, I'm going to go ahead and use this white one that I like better. So once I've got these guys all prepped and ready to go, the next thing that I need to start doing is getting all of my soldering done so that we are ready to go ahead and connect this sensor to the Arduino data logger. So first I'm going to clean up my bench and then I will show you the next steps. Okay, so I need one Adafruit Logger Shield. I need one Arduino R3 Uno data logger board. A Grove 2-coil latching relay. This is a Pololu 6-volt step-up, step-down voltage regulator. I need a plug. And then I like to have my rosin and my cleaning stuff. I'm going to want my screwdriver. I'm going to need some wire, but I'm going to go ahead and cut the lengths of those that I need off screen. I'm just going to get my primary components out and ready to go. And then I'm also going to get my soldering iron started heating up. I have a cordless soldering iron. It does not last forever, but it is handy when you've already got a million cords going around. Oh, and I need some solder. Okay, so here's my Arduino Uno data logger, and here's my Adafruit data logger shield. So this is going to go on top, and we use these little pegs to connect the two of them. They just slide in to these sort of breadboard guys, and you just break them off. So there's a little ridge on them, and you just break them. Which is why I like to have extras of these, though, because sometimes they break weird. But the long end goes down into the into the Arduino, and you just snap it off in the correct numbers. This last one is always the one that's tricky. Oh, and this has never happened before. They actually gave me one that's just a little bit short. So it's a good thing that I have my extras, because they didn't actually give me enough room. It's crazy. That's never happened before to do all of them. So this is why I have extras. Okay, so once all of those have one of those little pegs in there, and then there's another one that goes on this little section of 6 down here at the end, then you can go ahead and line up the holes on your logger shield with those, and it goes right through those holes. You can see that they're poking up through the top here. So that's what I'm going to solder, are those little spots right there. And there's a couple other things that have to get soldered in this set. So the voltage step up, step down comes with little spots to plug your wires into, but they're not already in there. So you have to put them in on the underside like so. You want to make sure that the holes are pointing outwards. And then these guys have like a little screw deal that you put the wire in, and you screw that little hole closed to tighten it down. But the first thing that you have to do is you have to solder this onto the board so that it stays together. So we'll do both sides of that. Okay, so those guys are going ahead and soldered on, and then they are ready to go ahead and use those guys. Okay, I've moved my camera so that it's much closer so that I can go ahead and show you a little bit closer up how this solder process goes. So I'm going to need to solder each one of these little spots where the peg is coming up through a hole on the logger board. Now I have some rosin paste that I'm going to use. I just take my solder and I just poke it straight into the rosin paste so it just gets a little bit on there. That just makes the solder flux a little bit better so that it ends up going down onto my join instead of getting stuck to the tip of my soldering iron. So we're going to go ahead and do this. And the way I do this is I take the soldering iron and I put it on that little middle bit and then I bring my solder in. And then we have a soldered spot. And I'm just going to do that all the way down this line. All right. Once I've got all of those soldered on, we're ready to start moving on to some of our next steps. We've got some other bits that we're going to solder together, but I'm going to switch back to the overhead camera so that you can see more of my workbench now that I've shown you up close how the solder works. Okay, and once you have finished all of the solders on the side, make sure you also solder these 6 down at the bottom. I forgot to do that when I filmed originally, and it meant that my SD card was not reading. So make sure that when you are doing all of your solders down these sides that you don't forget to do these 6 little solders at the end of the data logger. The next set of steps is going to be actually connecting the data logger to the sensor. So I need some stuff to do that. One of those things is some wire. I use this Adafruit, just 22 gauge solid core wire that I buy in a box altogether. I just actually used up the very last of my red wire. Any 22 gauge wire will work. This was just convenient for me to buy because I was already buying logger shields from Adafruit, and I do actually like the way it keeps everything contained in this little box. I take 4 lengths of that wire in yellow, black, red, and green, and I twist it together, and then I take one of these shrink dealies, and I put them on in 4 different locations and use the heat gun to shrink them. And that's my primary cable that goes from the sensor itself to the data logger and the latching coil and the voltage regulator. I've got my voltage regulator, which I've already powered here. I am going to need to get, or I've already soldered, sorry, not powered. I am going to need to get power to my data logger, and we are going to run this 9-volt AC/DC adapter through this voltage regulator before it goes to both the sensor and the data logger. And so I'm actually going to have to cut this cord, and then I'm going to connect it to some pieces of red and black 22 gauge wire to split it into multiple different locations. The other thing that I'm going to have to do is with this latching relay, I'm going to have to cut one end of this little 4-part cable that comes with it, because I only use 3 out of the 4 wires that are on here, and those are going to get plugged from the latching relay into the data logger. And then this is a little plug on the end of it that just actually one end plugs directly into the relay. And then the other side has these little screw ports that you put wires into, and then you screw them down to tighten them. So first things first, I need to strip the ends of my wires. And I'm just going to use my wire strippers for that. These are just normal wire strippers that you can get at the hardware store. These are my nice ones that I got as a Christmas gift. They're these Milwaukee ones, which I like quite well. And I'm going to strip both ends of both red wires and both ends of both black wires. And again, you just take your wire, you put it in your wire stripper. It cuts the plastic part on the outside, and you just pull on it, and it leaves the exposed wire on the end. So that's what I'm doing. I'm sure a lot of people already know that, but just in case there's a few people who don't know how wire stripping works. And the point of that is to expose the metal part of the wire so that I can use these wires to connect different components. And then I've got this green one, which is my communication wire that I also need at least one of. I'm going to strip it as well. And I might strip these ends just a little bit longer. The other thing that I have to do is I have to cut this power cable. Like I said, I've got just a normal AC/DC adapter. It needs to be cut so that I can use it to power multiple devices at once. So this plug would plug right into the data logger, and I could power the data logger just fine, and that would be great. But that doesn't provide power to the sensor, and I need to also power the sensor. So, and I want to do that all with one plug. You can also do this with a battery pack that has the same kind of data logger compliant end on it. But I use these pretty much always in the lab, so I have line wire. I want to make sure I have a pretty long end on the plug, or on the data logger side. of this wire. I've made the mistake in the past of not cutting this long enough, and then you don't have enough room to work with, especially because the wires on the inside of this tend to be pretty fragile. And so I'm probably going to make a couple of mistakes and have to cut it back more than one time. So I'm going to give myself a pretty long section here. And I'm just going to cut straight through it. And then if you look in there, I don't know how clear that is, but there's two different wires in here. There's a ground wire and a voltage wire. And I'm going to go ahead and I'm going to strip the outer section, and it should expose those two wires. Yep. So I stripped the outer coating, and I am left with two wires on the inside that are also coated separately. So now I need to strip these guys as well. These are really, really teeny tiny, so they can be very difficult to strip. They're too small for any of my little pre-sized strippers, and so what I end up needing to do is to just use the cutter section and be very careful while I strip these guys. Okay, and then once I've done that, you can see there's two little pigtails of copper wire that it produces. I'm going to go ahead and twist these up. And what I like to do is I like to tin these just to make it just a little bit easier to deal with. And so to do that, I take my soldering iron and I'm going to just apply a little bit of solder to the end of these. My soldering iron is not heated up right this second though, so I'm going to go ahead and strip the other end while I wait for it to do that. So I'm going to do the same thing on the wall end of this plug and go ahead and strip it just like I did that previous one. So I'm just going to tin these guys, I'm just going to take my soldering iron, I'm going to get a little bit of solder on the iron itself. You can see that there's a little bead of it on here. And then on these rosined up ends of wire, I'm just going to run it on down, and that rosin's going to help it stick to those wires. Of course, I picked up the non-rosin one first. Works a lot better if there's actually rosin on there. And so what that does is that just gives these wires a little tin coating, just makes it easier to deal with them without inadvertently breaking the little tiny copper wires that are in there. So again, I'm going to go ahead and pick up some solder on my iron, and then I'm just going to run it down this rosined section of the plug wires and just put a little coating of solder on top of those guys just to make them a little bit easier to deal with. Okay, and I like to deal with my power cord before I deal with anything else. It's just a habit that I have. So I've got my two red wires. And I am going to twist them together. And then I am going to connect those to the wall side. Sorry. I am going to connect those to the data logger side. So I've twisted these together. I'm going to connect them to the data logger side, and I'm going to connect them just to the red section, or this red wire here. So I like to first slide one of these heat wraps over the end of those so that it's ready to go for me, so that it's just slid on here. Then I'm going to go ahead and twist together both ends. I'm going to take just a little bit of rosin on my fingertips, put it on these guys. They do not really want to go together right now, but that little bit of rosin is going to help me out. Again, I'm going to get my soldering iron. I'm going to get solder on the iron itself, and then I'm going to go ahead and solder these together. I'm just loading up my soldering iron with some solder, and I'm just going to put it on this join between these two 22 gauge wires that I have joined together, and the plug, the red wire, the voltage wire, and of this, of the plug side of my power cable. So then once those are all soldered together, I'm going to let it cool down just a little bit so that it doesn't preemptively melt my tube. And then I'm going to cover that up with the tube. But I also need to go ahead and get the same thing done to the black side. So I'm going to go ahead and do that now. Okay, once these guys have cooled down, I'm going to go ahead and slide these little plastic heat sink or heat wraps over the top of them. A little tricky on the red side because I used a smaller one over there. Yeah, I think I might switch to a bigger one actually. And I'm just going to get my heat gun and shrink those down. And it just adds a little extra layer of security in that joint. And then, like I said, people are in and out of this lab all the time. This is a shared space. That means that if anybody who's not me happens to touch one of my sensors, they're not going to accidentally shock themselves. And so as you can see, it's just closed up that join entirely and covered it in this heat wrap. Okay, so there's the plug side done. That's ready to plug right into my data logger. Okay, so that I can connect it to power now. Go ahead and set this out of my way for right now, and we're going to do our next step. Okay, so remember I told you that one end of this 4-color sort of cable on this 2-coil latching relay we're going to have to cut. Go ahead and cut that. And then I'm going to peel apart the wires down here, and I'm only going to use the yellow, red, and black wire. This white wire is just going to get folded back out of the way. You can tape it back, or you can do like I do, and again, use one of these heat wraps just to keep everything a little bit more tidy. I pick a bigger one for this big flat guy, and again, I'm going to go ahead and melt that down so it's nice and flat. Nice and tight. And again, that's just my effort to keep things as tidy as I possibly can. So this end is going to get plugged into the data logger. I'm going to solder these 3 wires directly onto my logging shield. But this end, we're going to have some wires plug into it. So the first wire that I'm going to plug into it is going to be, it's going to be one end of this power wire that I have put together. And it's going to go just to this one NC marker here. And it just goes into this little hole, and then we twist down the top to keep it in place. So this is going to go to one NC. I'm going to get my handy dandy screwdriver. I'm going to tighten it down. I need to actually open it up first. I don't know if you can see this. I'm going to try. If I turn my screwdriver, this hole is closing up. And then if I turn it the other direction, it opens. So it just clamps down on this. So my red wire goes into one NC. I'm going to go ahead and clamp that down. And then the other thing that's going to go into this side next to this red wire is one end of this big multicolor wire that I made way back at the beginning. And it's going to be the red wire again. And that's going to go in the one COM port right next to this red wire I've just plugged in. Okay, so these guys are just both attached to this relay. Okay, this other side, I will show you what we're doing with it in a moment. Okay. And then the other things that are going to go into this 2-coil latching relay is the green wire, again, from that big cable that's going to connect to the sensor. That is going to go into one of these 2 ports on the right-hand side. It's going to go into the outside one, so the 2 COM port, and this is an actual communication table. Again, we're going to tighten it down, and you can see the wiring diagram for this in my paper, which I have linked to linked in the description. So you don't need to memorize the wiring diagram. You can use the wiring diagram that I've put in my paper. You can also use the wiring diagram in the Blackstock et al. 2019 paper. It's the same wiring process. The only thing that's really changed from the way that they made that sensor to the way that I make the sensor is that I'm putting it in the lid of a mason jar. And then I've skipped some of the waterproofing steps that they do. So I've done my green wire from the sensor to the 2-COM port. And then I'm also going to take this green jumper that I have made. So it's just a green 22 gauge wire that I have stripped both ends of, and it is going to go into the 2NC socket on this 2-coil relay. And I am going to tighten it down. Okay. Okay, now that I've gotten all of my wires correctly hooked up to my 2-coil latching relay, I need to get my wires correctly hooked up to my step up, step down voltage regulator. So if you look at the bottom of this step up, step down voltage regulator, you're going to see one side that says V in and ground, and one side that says V out and ground. So the voltage in, V inside, is going to take the red wire from the wall. So it's going in, and the black wire from the wall. So the red wire goes into the voltage socket and the black wire goes into the ground socket. And you're going to do the same thing as what we were doing for the relay, which is you're going to put them in the holes on the end here, and then you're going to use your screwdriver to tighten down these little grippers to hold these wires in place. Okay, so that's the voltage inside and the ground from the wall. So my wall is my in. I'm just going to snug this up a little bit off camera because it's hard to do that while holding it up in the air so far away from my face. Okay, once I've done that, I'm now going to take my one remaining red wire from the data logger side of my power plug, and I'm going to put that into the voltage out. And then I'm going to take a single black wire also from my split black wires that I have put together here, and I'm going to put that into my ground on the outside of this step up, step down regulator. Okay, once we've done that, we've got these guys connected, those guys connected, we're ready to go. Just on this voltage regulator, you can connect these sockets either on the bottom or on the top. Either way is fine. I usually actually do it the opposite way of this way. I'm just trying it this direction for the first time. So we've got my power mostly figured out. I've got one ground left that I need to deal with, and you're going to see that when I get to it in a few minutes. But we're most of the way there. Okay, so the first thing we're going to do is we're going to deal with that one last ground wire, and this wire is actually going to go ahead and connect to the sensor. So this 4-color wire that I've put together is going to connect to this ground wire, and that's the last sort of power wire that we need to deal with. Again, I'm going to, before I even put them together, I'm going to get a heat wrap and put it on one side just to make things easier for myself. I'm going to make sure that I haven't tangled any of my wires around themselves before I get these guys connected to one another, and I'm just going to twist them together. And then once they're twisted together, I'm going to solder them together. It's just a little tricky to get them twisted together. Sometimes it's easier if you give yourself a little bit longer wire, which I'm going to do now. I'm going to strip just a little bit more of this wire away to make twisting these guys together just a little bit easier for me. Okay, that's completely twisted together. I'm going to take just a tiny bit of rosin on my finger and rub it on there just to help it flux a little bit better. And then I'm going to go ahead and load up my soldering iron with some solder and spread it over this join. I'm just going to check the underside, make sure that join's good all the way around, and it is. And then let that cool down a little bit before I pull the heat wrap over the top of it. Okay, get my heat wrap on. Now you could, in theory, just make this black wire extra long. And have it go all the way into this split join, but I have found it easier to just make this little pigtail with the two wires and then connect these two wires together when I'm doing this. Okay, so all of my power is dealt with. I've got my plug, I've got my voltage regulator, everything is powered in. I've still got some more wires that I need to deal with here, so let's go ahead and get everything connected first to the data logger, and then we will get everything connected to the sensor. So these guys that need to get connected to the data logger need to be stripped. These are those little bits, these little ends from the 2-coil latching relay, little 18 gauge wires. These are not solid core, so there's a bunch of little tiny wires together inside each of these. Just be aware of that while you're stripping them. They can be a little bit delicate. Twist them together. I don't usually tin these ones because it just makes it a little bit harder to get them into the data logger. Okay, so making sure to keep all of my cables untwisted as much as possible. I now have to make some connections from the sensor and my 2-coil latching relay to my data logger. So my communication cable is going to be this green one that is coming out of the 2NC port on the 2-coil latching relay. And that guy is going to go plugged into space number 7 on my, or space number 9 on my data logger. Yeah, space number 9 on my data logger. So I'm going to take my soldering iron. I'm going to get just a little bit of rosin on the end of this guy. And I'm going to go ahead and pop it right into space number 9 on the data logger. And then I'm going to heat up the join and then bring my solder in to connect it. So you can see that I've connected it right there. And then space number 8 is going to take this yellow wire that's coming from the sensor. Okay, so this is that big 4-part wire that I've made for myself. Again, a little bit of rosin. And we're just going to go ahead and pop that into space number 8. And go ahead and solder that joint together. And then my last communication cable is this yellow one coming from the 2-coil latching relay, and it is going to go into space number 7 on the data logger. Get that in place. This one's a little harder to get into place. It wants to spring out of that spot. Oh, and I haven't gotten any rosin on it. So I'm probably going to like preload some solder on my soldering iron for this one, just because it doesn't want to stay put. Again, put it in the space and go ahead and just solder that join. Once those three are in, we just have 2 more wires on the data logger end, and that is my 2 power wires. And again, I want to make sure that I'm not getting my wires too twisted up if I can avoid it. It's not always totally avoidable. when we're doing this, but now is the time where you have the best chance of not getting them too tangled with one another, because once everything is soldered into place, it's really hard to untangle everything. Put these guys over here. The nice thing about this latching relay is you can always just unplug it. Plug it back in. Okay, so the red and black wire that are coming out of the 2-coil latching relay are the red and black wire that connect to the 5 volts and the ground sockets on the data logger. And I actually have an incomplete weld on this data logger, so I'm going to go ahead and get that first. And then I'm going to go ahead and put these guys into the appropriate holes. It's a little bit odd because they get a little bit offset after ground, but if you find the 5-volt location correctly, the ground is just the very next one next to it. And that one is labeled pretty well. Pop these guys down in there, again with a little rosin paste, and we're just gonna solder these 2 joints. Okay, there we go. We have all of our data logger connections done. We have all of our power wired up. The only thing left to do at this point is to wire the actual sensor itself. All right, now that we've gotten the data logger all wired up, the only thing left to do is to connect the wires to the sensor. So I have placed the wires. I've just put a little bend in them. I haven't soldered them yet. I've placed them in their correct locations on this sensor. I can't quite get it to focus. I really recommend that you look at the wiring diagrams either in my paper or in the Blackstock paper to be able to tell exactly how to get these in. But to try to explain it, we're in order from outside to in. We go black, red, yellow, green, or sorry, black, red, green, yellow. Said it wrong right off the bat. And we are in the second row of dots in on the bottom row of the sensor, and then you come in at least 1 dot in from the 1 hole in from the outside edge. But again, check the wiring diagram. That's going to make it a little bit easier for you to be able to see this. Let's see if I can get it to focus. So this is how this is going to get wired up. So I'm going to go ahead and solder these spaces. I'm going to use my wire cutters to hold this guy down because it wants to spring up. Okay, you can see that I've got that wiring all soldered in. And so now we just need to check to make sure that this works before we attach it to the lid. Because once we get it epoxied in, we can't do any rewiring. And you can see by some of the extra solder that I've got on here, I've already made 1 mistake wiring this today off camera. So we're going to make sure that we check it beforehand. All right, now I'm going to go ahead and check to make sure this works. This is the point when we get our laptop out. And I'm going to go ahead and screen capture this so that you can see what I'm doing with my laptop. So first things first, I have plugged my printer cable into my computer. I'm not going to plug it into my data logger just yet because I have to have my Arduino program open before I do that. So I'm going to go ahead and go onto my computer. I'm going to go ahead and open my Arduino IDE application. I am obviously doing all of this on a Mac. You don't have to use a Mac. You can use any computer. Arduino is compatible with Windows machines as well. Okay, and then I am going to select a sketch from all of my selection of sketches here. I think I'm going to use this 10-second sketch. So these sketches were originally written by Joseph Meyer and modified by Matt Covington to add power cycling. That's what you're going to want to use if you are running your sensors on a battery, because I plug directly into the wall. I do not use the power cycling. And then I have turned off some of the other functions in this program, and then I have changed the timing, the read interval timing, to 10 seconds for my warm up when I'm just testing my sensors or when I am adding CO2 to a mesocosm, so that they're running pretty quickly. And then once I get to the point where I'm going to let them run for several days, I have them take readings every minute. I originally tried doing this at 10-minute intervals, but I realized that I wasn't coming anywhere near filling up my SD cards, and I was missing a lot of the really short time variability in my mesocosms, in my respiration. So I decided that I was going to start doing these at a 1-minute interval for the actual experimental readings that I do. But just to warm up and start the sensors, I always start with a 10-second reading just because it's faster to do it that way. Before I do that, I do need to actually add an SD card to this data logger, which I'm just going to run around the corner and grab real fast. I'm just borrowing a SD card from one of my other sensors. And now that I've got that in, I'm going to go ahead and plug my serial cable into my data logger. And then I'm going to go ahead and plug this into the wall, because while it gets enough power from the computer to upload the program, it doesn't get enough power from the computer to actually run the sensor. Once I've done that, I'm going to come back to my computer and I'm going to select the port that I'm currently using. And then I'm going to go ahead and have it upload this sketch that I have run. I'm just going to double check and make sure the file name is correct. And the reason I'm doing that is I want to make sure that I don't end up with the wrong file names on this SD card and confuse it with my data from my actual sensors. And we do have the right file name, so I'm just going to use this right arrow button to upload the sketch. And then I can use the serial monitor to check and make sure that it's actually reading. So it's always going to come up with a value of 0 for the very first reading. I'm just going to wait 10 seconds to see what the second reading is and make sure that we've got this running. Okay, second reading is 370 degrees, so it looks like our sensor is working. The other thing that I'm going to check to make sure my sensor is working is I'm going to go ahead and look for this set of orange lights that flashes across the sensor periodically, which is great. Now I'm also going to test to make sure that it's going to measure when I increase the CO2, and I'm going to do that by just breathing onto the sensor. Okay, it did something weird there. I think I probably just moved these. Yep, I just moved the wires around a little bit. This feels a little loosey-goosey. I might tighten the solder on it up, but you can see that the CO2 concentration has gone up really high. It's gone up to 24,000 and then 10,000, and it's coming right back down again now that I have stopped breathing into the sensor, which is exactly what we want to see. So this guy looks like it's working pretty well. I do have one solder that looks just a little bit loose to me, so I am going to go ahead and fix that solder up. But then after that, we're ready to epoxy my sensor onto the lid. So I will bring you back when we're ready to do that part. So it's now time for me to go ahead and use some epoxy to glue this guy down into the lid. And the same with my SEPTA here. Now I did have to, because there's a little bit of a raised section on the bottom where I soldered the wires in to wire the sensor to the data logger, it wasn't sitting quite flush against this lid. And so I just used my Dremel tool and I cut myself just a little groove for those to sit down in. And it's sitting much flatter now. You can see it's sitting pretty flush against the lid, which is exactly what I want. Now, there's still a really thin layer in between here, but we are going to fill this in with epoxy. The other thing that we need to epoxy in is our septa, and then we will be able to actually use our sensor. So it's time for me to get some epoxy out, which is why I have my gloves on, because I don't want epoxy on my hands. I don't really like any sticky stuff on my hands, but epoxy especially can really irritate your skin. I am going to use this marine epoxy. It's a putty epoxy that you can use. It's very moldable. I always use this first before I use any liquid epoxy because I can use it to sort of stick stuff down so that it's nice and firm, and then I can fill in the gaps with a liquid epoxy. So the way that this stuff works is it comes in a tube. It's wrapped in plastic, and then it's just, there's two different types of material here. There's this green stuff on the outside and there's gray stuff on the inside, and you have to mush it all together to activate the epoxy. So I'm going to twist off a good chunk of it for myself, not too much because it does set really fast. And so if I take a whole bunch, then I'm not going to be able to use it before it turns hard. And then I twist the top closed so that I can reuse this epoxy. Pop it back in its little tube, put the lid on, and that's how I make sure that I'm not like constantly having to buy fresh tubes of epoxy. One of these tubes will probably do 3 or 4 mesocosms total, as long as I make sure I seal it up really good. So I'm just going to mush it together. It smells really bad, and so this is a good thing to potentially do under a fume hood if you're able to do so that you don't have to deal with the fumes of it. But if you're not going to do that, I'm wearing a mask right now, so you can wear a mask to help with that. Okay, so now I've got that completely incorporated. I'm going to go ahead and I'm going to roll out some like coils that I can use to glue this down. And I like to take my coil that I have rolled out. I'm going to roll it out a little thinner than this. I might do it in some pieces just to make it easier on myself. Roll out my coil, and I'm just going to put it around the edges of where the sensor is located. Okay, so I've put just sort of a circle of this epoxy all the way around the sensor and a little bit over that spot where the wires were sticking out. And then I'm going to go ahead and I'm going to attach it to the lid. So I just squeeze that in nice and tight. And this is just overlapping a little bit. So that's going to get nice and start to cure there. And then before this cures, I'm going to go ahead and use some more of this to get the septa in. And I'm going to change my gloves. These ones have gotten a little sticky. I'm sticking to the epoxy. I'll grab a couple more gloves and start fresh. Again, always a good idea to have gloves on hand to deal with epoxy. It can irritate your skin, but it's also, I don't like having sticky hands. So I'm going to push this guy through, and then I'm going to go ahead around the outside. I'm just going to use the epoxy to seal up that little seam. Okay, once I've done that around the top, I'm also going to go around the edges of the circuit board portion with some more of this epoxy. And I might have to mix up a little bit more epoxy, but I'd rather mix up not quite enough and have to do more than mix up too much and have it go hard on me before I can use it. And I just want to seal up as many places where air can get through as possible. I am going to go over this with some Plasti Dip as well. So this is not my only method of sealing these guys up, but I just like to seal as much as possible to really just make sure that we can get this guy as airtight as we can possibly manage. Okay, so there's a couple spots that I haven't sealed up yet, so I am going to mix up a little bit more epoxy. You can see there's a hole in the circuit board right here, and the liquid epoxy that I'm going to add to the top of this after it cures could potentially go through that and interfere with the sensor. So I want to make sure that I get that blocked up over the top. Other than that, I've mostly gotten all of this space filled in. I used to also like to go around the inside, but I have found that that can interfere with my ability to close the mason jar well, so I don't really do that anymore. What I will do is I will take some Plasti Dip and just paint the seams on the inside here, but we will do that after all of the other epoxies have cured. That'll be probably another couple of days from now before I do that. So this is that first set of epoxy. I'm going to just mix up a little bit more so I can fill in just a little bit better, and then we'll let that cure for about 15 minutes before we put the liquid epoxy in, and then I'm going to move this into the fume hood so that it can finish curing overnight and not stink up the lab. So part of what I'm doing here is I'm making a little bit of a dam so that when I do put this liquid epoxy in, it doesn't sort of overflow the edges of my lid and make a giant mess. Because I am going to fill in basically this whole area here with a liquid epoxy just to really seal up all of my edges. And then at the very end of that, I'm going to go over the entire thing with Plasti Dip as well. Okay. I've got my marine epoxy pretty well set the way I want it to go. I'm going to make one more ring around the outside here so that I can epoxy in right along these edges, and that's just going to help with the airtightness. All right, we're going to let that cure for 15 minutes, and then we're going to come back and we're going to add our liquid epoxy. The marine epoxy has firmed up. It's not completely cured, but it's at least firm enough that I can go ahead and fill in the rest of the area with this clear liquid epoxy. So I have some JB Weld Clear Weld quick setting epoxy. It comes with this little tube that mixes these two different sides together as you squeeze it in. So this is an easy one to use. There are some other versions out there that you can use. Basically, any liquid epoxy is going to work. I'm just grabbing this one. Okay. So once I got that lid stuck on there, and I've got it all over my hands, which is yet another reason why I wear gloves when I deal with sticky stuff. I'm just trying to seal up the seams as much as possible with this liquid epoxy, just so that this is not where air is getting into my mesocosm. Okay, and I've used up pretty much all of the epoxy in this container. This is one of the smaller squeezers. They come in larger sizes, but this is the smaller one that I'm using. And I'm trying really hard not to get the epoxy on the outside. I'm going to seal up this outside section with the Plasti Dip rather than the epoxy, just because the epoxy runs down the sides and it's really no fun when it does that. So now that I've filled this all in with epoxy, I'm going to go get rid of this epoxy tube. The way that I do that is I usually actually just put it inside of one of my gloves and then inside of the other glove so it doesn't leak all over the place and the janitors don't have a mess to deal with. And then this is going to go into the fume hood to cure overnight. And so I will pick back up tomorrow to show you the next steps. Okay, so I made a mistake while I was recording this and there is no audio. I have no idea what I did, but there's no audio on this section. So I'm just going to go ahead and narrate it over the top of the video. So what I'm doing here is I'm unsealing my jar of Plasti Dip, which I just wrap up with tape and a glove to keep it from getting turning to rubber, to solid rubber, basically. The lid on them does not hold tight very well, and so I do extra seal on it. This stuff has a pretty bad fume as well. I normally would do this under the fume hood instead of on top of the counter, but I'm just going ahead and doing it here, and I'm just showing you that a skin forms on top of it. Over time, even with all of the lid covers and sealing methods that I use. But once I get into there, I just peel that skin back a little bit, and then I just get the liquid Plasti Dip onto a paintbrush. And then what I'm going to do is I'm going to take that liquid Plasti Dip on the paintbrush, and I try not to do it too thick of an application, because if you do a really thick application, it not only takes forever to dry, but it also just kind of like gums up and doesn't seal as well. And then I'm just going to very carefully run this Plasti Dip, and you can see it's kind of gummy already, along the seams between the marine epoxy that I put on and the actual plastic lid, because I just want to seal out that outside edge. What I don't want to do is come too far down on the sides of it, because when you go too far down on the sides later on, when I'm putting some electrical putty on the container, like what I just showed there, the electrical putty will get stuck to the rubber, the liquid rubber, and it will peel it back and it'll ruin that seal. So you do periodically have to reseal it no matter what you want to do, but I do my best to avoid having to do that more often if I can. So I'm just going to seal up all of the joints and try not to go too far down on the sides. And I will probably speed this part up because I don't know that you need to watch me painting an entire lid of plastic dip. Okay, it looks like I'm almost done with the plasti dip. I've coated most of the edges here, so I'm just gonna go ahead and show you the top of it where I have made sure the plasti dip is basically on any spot where epoxy is meeting lid or marine epoxy is meeting lid or epoxy is meeting marine epoxy, just to make sure that all of those little potential joins are completely sealed up so that there's no possibility that air can possibly get in. And then what I usually do is I take that plasti dip and I'm going to go ahead and I'm going to put it in the fume hood because it does have a little bit of an off-gassy smell and I don't want to subject everybody in the lab to that. Put it in the fume hood to cure overnight. Plasti dip cures pretty quickly, so especially if you're going to use multiple layers, you can actually just let it cure for maybe an hour and then come back and put another layer on. But for me, I'm usually just putting on one layer at a time. I pop it in the fume hood overnight or just until the next time I happen to be coming into the lab. And then it looks like I'm showing you how I seal up the jar again. Again, I just pop that lid on. The lid does not seal very well at all, and so I wrap tape around it. And then once I've got the tape on it, I use my super high-tech glove to finish sealing it up. Okay, so it looks like I'm coming back into the lab after we've gone ahead and let that plasti dip cure. Again, my audio was not working that day. I did not realize until much later. So I'm just demonstrating, again, I've sealed it up, but I didn't let the plasti dip come all the way down the sides of the lid because when you do that, it sticks to the electrical putty and then peels up every time you pull that electrical putty off. And it just makes it so that you have to redo that plasti dip sooner than you otherwise would. Because you're repeatedly using these things, the plasti dip's eventually going to peel no matter what you do. But if you can actually slow that process down so that you don't have to reseal them regularly, it's just a lot easier to use them for multiple incubations. And so to do that, I just don't let the plasti dip come down the sides of the lid. Okay, so now that I've got the whole thing sealed up and I've got my sensor plugged into my data logger, I am going to go ahead and I'm going to connect it to a mason jar, get it connected nice and tight, and then I'm going to do a leak test essentially at this point. And so I'm going to seal up my mason jar. I'm going to take some electrical putty and I'm going to roll out some electrical putty coils. And then I'm going to wrap that electrical putty around the edges of the lid, just anywhere that I can't preemptively seal with epoxy. I'm going to go ahead and add that plasti dip. Now, these lids with the rubber gaskets, they seal really, really good. And so I might not even need the electrical putty, but I've never actually tested one without putting the electrical putty on it. And so in this case, I just put that on as basically an extra layer of protection. I don't think it's actually doing a ton in terms of making those jars airtight. It's just, another layer after all the other airtighting methods that I have used. And so I'm just going to squish it right into the seam. The great thing about electrical putty is that you can basically use it indefinitely as long as you don't get anything dry on it, like dirt or flour or anything like that. It will keep sticking to itself. But again, I'm showing you that I'm wearing gloves because I really don't like sticky hands. And so it does create like a little residue that it leaves behind on your hands. That's not great. So once I've got that all the way sealed down, I'm just checking all of my edges and making sure it's completely adhered to both the lid and the jar. And then I'm going to make just another little ball of electrical putty that I'm going to tuck into the top of the septa. But I won't do that until after I have gotten some gas into the jar. So I'm just showing you what the entire thing looks like when it's got soil in it. And you can see that there's some residue left behind from the electrical putty on the jar, which is, again, why I wear gloves. Okay, so now I'm grabbing some CO2, one of my many jars of calibration gas. I have these in 500 parts per million, 10,000 parts per million, or 1%. 50,000 parts per million, and I think I've got one that's at a 5,000 parts per million, so 0.5%. I don't know which one I was using on this particular day. I do know that this mesocosm was not a leaky one, so the test worked. I just basically plug in the uh, canister that has the compressed calibration gas in it, and then I put just like a needle as a pigtail to let the excess gas out. And then I'm going to turn on the gas and let it flow into the jar until the jar fills up. And in order to make sure that the jar is filled up, at this point, I usually connect it to my computer so that I can look at the concentration as it's increasing in the Arduino program that I've showed you in other videos. So you can see that pigtail to let the gas out and that tube letting the gas in. So I'm not gonna go ahead and keep narrating this entire video. I'm gonna go ahead and cut it back. But essentially what I do here is I just fill the jar up with gas. Once the CO2 concentration is at least close to what the calibration gas concentration is, it is a little bit tricky to get these jars precise to the calibration gas just because there's the ability of air to get in through the pigtail, and it's easier when the jar is empty. When the gas has soil in it, it takes a really long time because there's gas in the soil that's also going to diffuse back and forth with that and displace some of the gas in the mesocosm, but it does take some time to get these filled up. So I will fill up a jar with a calibration gas. I usually do it with multiple different types of calibration gas because your leak rate is always going to be faster when the CO2 concentration is higher in the jar than it is out of the jar. So I'll go ahead and fill up that jar, make sure that I get it to a calibration or close to the calibration standard, and then I will let that sit overnight and see if the concentration decreases in the jar overnight while it's sitting there. And then I will do it again with a higher concentration calibration gas and see again if that happens. There's usually at least a tiny little bit of leak, 1 or 2 parts per million to as much as 1,000 parts per million. If I've filled the jar up with 50,000 part per million gas, it's probably going to leak considerably more than when the jar is filled up with 500 parts per million gas, just because the concentration gradient between the inside of the jar and the outside of the jar is way higher. That flux is going to be a lot faster in that case, even if it's just leaking really tiny. This jar with these new white lids, they hardly leak at all. It's great. But I do put a little, do a little leak calibration on these guys to make sure, in addition to the gas calibration, to make sure that I am accounting for that leak with these jars. So that is what I'm doing here. And that is the end of my video on how to construct a mesocosm. If you have any questions, you can certainly email me. You can contact me through my email address, myfuji@wsu.edu, or you can contact me through through YouTube, and I will be happy to answer any questions that you have about constructing mesocosms.